Okay, guys, so we're gonna talk a little more in detail on graphing quadratic equations in standard form. I'm gonna go through another example a little slower, okay? And then I'm also gonna talk about maximum and minimum values. So make sure you're paying attention. And obviously, like always, if you have any questions, make sure that you reach out. Okay, so in this problem number 22, we're gonna graph this thing following the steps that we did earlier, which are listed right up here. Okay, so first things first, step number one is to identify the coefficients. Okay, the A is the coefficient or the number that's always attached to the x squared. So A is going to be equal to 3. B is the number that's attached to the x. So that's going to be -6. And then C is the constant. C is by itself on the outside there. So C is going to be equal to 4. So we've identified the coefficients. Our next step is to find the vertex. Okay, and the vertex is going to do two things for us. It's not only going to tell us the vertex, but it's also going to tell us where our axis of symmetry is. So first thing when we find the vertex is we find the x-coordinate of the vertex, which is -b divided by 2a, which in this case, the opposite of b, here's our b value. The opposite of b, which is -6, is 6 on top of 2a, which would be 2 times 3, okay, which would be 6 divided by 2 times 3 is 6. 6 divided by 6 is equal to 1. So the x-coordinate of my vertex is 1. That is also going to be my axis of symmetry. So your axis of symmetry is located at x equals 1, which is right. Oop, that is way too thick. So your axis of symmetry is going to be at x equals 1, which is right. That's still too thick. Jeez. Got to get myself a thinner marker here, guys. Sorry. All right, we'll go to the 1 millimeter. So x is equal to 1 right there. That's better, much better. Okay, so there's your axis of symmetry. So wherever it is that my parabola is, that's where it's going to be flipped over. Now, I probably should have done this from the start, but I'll go back and do it again. If you look at your A value tells you a lot of things about the graph. First of all, if it's positive, which it is in this case, you're going to know that it's opening up. So my parabola is going to open up. Secondly, if your A value is bigger than 1, which in this case it is, that's going to make your graph skinny, right? Skinnier than your parent function of y equals x squared. So when I finish my u and I do everything correctly, and hopefully I do, I'm going to finish with a parabola that not only opens up, but is skinnier than the parent function graph that we talked about earlier. Okay, so once I know the x-coordinate of my vertex, then it's time to find the y-coordinate. The only way to find the y-coordinate is to take the x-coordinate and plug it into that equation. So that's going to look like this: 3 times 1 squared minus 6 times 1 plus 4. 3 times 1 squared is 1, minus 6 times 1 is 6, plus 4. 3 times 1 is 3, minus 6, plus 4. 3 minus 6 is -3, plus 4 is equal to 1. So the vertex of my parabola is 1, 1. So your vertex is going to be 1 right and 1 up. So there's my vertex right there. And I know my parabola is going to go up. Okay, so I found the vertex. The next step is to identify the y-intercept. The y-intercept of any parabola is 0, c. 0, whatever the constant is. So in this case, it's going to be 0, 4, because my c value was 4. So your y-intercept is 0, 4. Your y-intercept, guys, is always going to be on the y-axis. That's why it's called a y-intercept. Your y-intercept is 0, 4, which is right there. Okay, now that's going to help us find another point, because remember, this is symmetrical. So if I flip that dot over my axis of symmetry, I'm going to land right there. Okay, so you can kind of get a feel for what my u is starting to look like here. The next step, and this is the second to last step, you're going to pick another value of x, okay, and figure out what the y value is that goes with that x. So let's pick an x that we haven't used yet. I use 1, right, because 1 is my vertex. I got this point at x is equal to 2. I have this point at x is equal to 0. Let's see what happens at x is equal to 3. So when x is equal to 3, okay, that means you got 3 times 3 squared minus 6 times 3 plus 4. So I'm just going to work through some arithmetic here. 3 times 3 squared is 9 minus 6 times 3 is 18 plus 4. 3 times 9 is 27 minus 18 plus 4. 27 minus 18 is 9. 9 plus 4 gives me 13. So that means the ordered pair 3, 13 is on my graph. When x is equal to 3, y is equal to 13. 3, 13 is on the graph. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I had to go a little bit off my grid. Okay. If I extend that axis of symmetry up a little bit this way. All right, and I flip that point over the axis of symmetry. Looks like it's going to be roughly right there. Obviously, this is not perfect. Okay. And then last but not least, guys, you draw your parabola. Okay, as I said earlier, it's opening up because A is positive, and it's skinny because A is greater than 1. Okay, so there's our final product. All right, lastly, guys, I just want to talk about maximum and minimum values. Okay, we're not going to take too long on this. Okay, a graph is going to have a minimum value if it opens up, like this graph right here. Okay, a minimum is the lowest possible number something can be. Okay, so when the graph opens up, that means it has it means it has a bottom. The bottom, which is the vertex, that's your minimum. When a graph opens down, like that parabola does, that means it has a top. If it has a top, we call that the maximum. Now remember, we can figure out right away whether the graph opens up or opens down. We just look at our A value. So in number 22 here, my A value is +3. +3. So this graph is going to open up in some way, shape, or form. And since it opens up, that means it has a minimum. That means it has a bottom. In number 25, your A value is -1. -1. Since it's negative, you would have a parabola that opens down, which means it has a top, which would give it a maximum. Now, to find exactly what the minimum and maximum are, you would find the vertex. Okay, so I'm going to take number 22 and bring it up here where I got a little more room. The x-coordinate of the vertex, remember, is -b on top of 2a. So for this one, -b, b is -6, so the opposite of -6 is 6, on top of 2. I actually already did this one for you guys, and I just realized it. Okay, so I'm not going to go through all the work again because it's all the way up here. I didn't realize I doubled up on a problem there. But the vertex of this graph, when we graphed it, was 1, 1. Okay, the vertex, like I said, was 1, 1. So that's going to be your minimum value. Okay, your minimum value here is the vertex, which is 1, 1. Okay, I'm sorry, I thought I picked a new problem. I guess I didn't. Your maximum value for number 25, we're going to find the vertex. This is a new problem, so we'll be able to find it. So I'm going to take it and bring that one up here since we got a lot more room up top. Okay, so the x-coordinate of any parabola is -b on top of 2a. So for this one, it would be the opposite of b, which is -2. So +2 on top of 2 times a, which is -1. So I got 2 over 2 times -1 is -2. And 2 divided by -2 is -1. So there's your x-coordinate of your vertex, of your maximum. To find the y-coordinate, I take that -1 and I plug it in. So it would be negative, stay with me here, -1 squared minus 2 times -1 minus 1. Be careful in the front because that first negative right here is built into the equation. The second negative is from this ordered pair right here, that coordinate right there. So I got negative 1 squared is positive 1, so that makes it a negative 1. I know that's kind of weird. Negative 1 squared is 1, and then it gets in front of that other negative. A negative 2 times a negative 1, negative times a negative makes it a positive, plus 2 minus 1. Negative 1 plus 2 is 1. 1 minus 1 is 0. So the y-coordinate of your vertex is 0. Okay, so there's your vertex. Now, when they ask you for a minimum or a maximum, they only need the y-coordinate. So in number 22, the minimum is 1. And in number 25, the maximum is 0. Okay, so hopefully that clears things up as far as minimum and maximum are concerned. You're going to know right away if it opens up or down, which means you're going to know right away if it has a max or a min. And then to find the max or the min, you're finding the vertex, which hopefully by now you're comfortable with, and the y-coordinate of the vertex, that is your maximum or your minimum.